Hello and welcome students. The last topic for this week is OSI reference model. We will see the comparison of the TCP IP model that we have already covered with a new model, that is the OSI model. The roadmap for this lecture: first we will see the outcomes and then the OSI reference model and its layers, and then we will compare the two models, and finally we will see the lake of success for the OSI model. The outcomes are mentioned here. You will see the different layers of the OSI reference model, and you would be able to present a comparison of the two models and also the lake of success for the OSI model. So here is an introduction to the OSI reference model. We have already covered the TCP IP protocol suite or protocol model. However, that is not the only model that is available to the network community. We do have another reference model, that is the OSI. In 1947, the International Standard Organization ISO, which is a multinational body and that is dedicated to the worldwide agreement on developing international standards. Okay, so the ISO standard that actually cover all aspect of network communication is commonly referred by OSI model, open system interconnected model, interconnection model, and this was actually the first step toward internationalization of the protocols that is used in various layers. And this OSI model was first introduced in 1970s. An open system is actually you can say a set of protocols at different layers that will allow any two different systems to communicate with one another regardless of their underlying architecture. So the purpose of this OSI model was to show how to facilitate communication between different systems without requiring changes to the logic of the underlying hardware and even software. This OSI model is actually not a single protocol. It is a model for understanding and for designing a network architecture. So this is basically a model that was intended to be the basis for the creation of the protocol in the OSI stack. Like the TCP IP model that we have studied, the OSI model is a layered framework. Okay, mean we have different layers, and this is helpful for the design of network system that will allow communication between all types of computer systems. In the case of TCP IP model, we studied that we have 4 or 5 layers. However, in case of OSI model, we have 7 different layers. What are those layers? Let's see them. This is something which seems similar to the model that we have already covered, the TCP IP. What's different are the two topmost layers. At the top we have the application layer, and then we have the presentation layer, and then we have the session layer. In the TCP IP model, we do have the application layer, but the presentation layer and the session layer was not present there. Yes, we do have the transport layer, the network layer, the data link layer, and the physical layer. So the functionality of every layer defined here, like the transport, the network, the data link, the physical, and the application, they are exactly the same as we defined in the TCP IP model. However, what's new for us is the presentation layer and the session layer. The role of the presentation layer in the OSI model is to provide services that allow communicating applications to interrupt the meaning of data exchanged. These services include data compression, data encryption, and data description. These are some of the services provided by the presentation, and it helps the application from having not to be worried about the internal format in which data is presented. For example, the format may be different from one computer to another computer, but you don't need to be worried about that because the presentation layer will handle these things for you. So it is like the presentation of the data to let you free from different formats. Okay, that is like the makeup of the data is the functionality of this presentation layer. And we do have a session layer here, and this session layer provide for delimiting and synchronization of data exchange, including the means to build a checkpointing and recovery scheme, something like that. So that is like the fact that internet lakes the implementation of these two models that are found in the OSI reference model. Okay, and also there it leads to some question why we do not implement these two layers in the TCP IP model. Are the services provided by these layers, like the presentation of the data and the session established between two devices, whether they are not important, that is why we are skipping them? Or if an application needs services of these two layers, then what will it do, because the layers are not present in the TCP model and the actual implementation of the internet is based on the TCP model, not on the OSI model. So the internet answers both these questions in the same way, and that is that it is up to the application developer to decide if a service is important, and if that is important, it is up to the application developer to build that functionality into the application itself. Okay, so that is like if you need the services of the presentation or session layer, just implement them in your application. So that has been left to the developer. Now if you compare the two models, the first thing, the major difference that you would see here is in the first three layers. In the OSI model we have the two extra layers, while the functionalities of those layers are embedded in the application itself. So the OSI application layer is similar to the application layer in the TCP IP protocol suite, but the next layer in the OSI model, the presentation layer, actually perform a series of functions necessary for presenting the data packages properly to the sender or receiver. Okay, for example, the presentation layer might perform ASCII to non-ASCII character conversion, and it also perform encryption and decryption for securing your communication, and it also do the compression of the data into smaller unit. But at the TCP side there is no separate presentation layer. The application layer in this model is usually considered to be the combination of these three layers, which mean the functionality provided by these three individual layers will be combined into this one layer. And some of the functionality of the session layer are also available not only in the application layer but also in the transport layer. So you can implement some of the functionality of the session layer at the application layer, and some of the functionality of the session layer at the transport layer. Now let's see why this OSI model was not successful. Remember, the implementation of the internet is based on the TCP model, not on the OSI model. Although its OSI model was proposed much before, or it appeared before, after the TCP IP protocol suite model. Yes, the OSI model is like the latest form of the TCP IP model, but still it is not implemented. So most of the experts were at first excited about the TCP IP protocol suite, and later on they thought that the TCP would be replaced by the OSI model, but it did not happen for several reasons. Why? The first reason, The OSI was completed when the TCP IP was fully implemented or fully in place, and a lot of time and money had been spent on the TCP. So changing from TCP to OSI would be a costly, you can say a costly approach. So that is why they prefer to stay on the TCP IP model. There is another reason for not implementing the OSI model, and that is that some layers in the OSI model were never fully defined, like presentation and session layer. We saw that presentation layer is responsible for encryption, decryption, and also for compression and things like that for security purposes, but other responsibilities were not clearly defined. So some of the layers in the OSI model were never fully defined, like the services provided by the presentation and the session layer were listed in the document, but actual protocol for these two layers were not fully defined. Okay, so that is another reason that if something is not clear, how you can adopt that thing for implementation. And the third reason is that the OSI was implemented by an organization in a different application. It did not show a high enough level of performance, right? Like its implementation was not that much successful. At a smaller scale, it was not successful, and it was not able to encourage to motivate the internet authority to switch from TCP protocol suite to the OSI model. And there are also other reasons like the bad timing of the OSI model and things like that, but these are the three common reasons for not successing for not succeeding in the market, in the internet market. Thank you so much for watching the video. Take care and goodbye.